Making the next presentation, Fernando Gont. IPv6 for multiple routers, interfaces, and prefixes.
Ahí va. A ver, creo que es para atrás esto. Ahí va. Bueno, buenos días para todos. Gracias por...
Good morning. Thank you for joining us today. I'm Fernando Gont. I will be making a presentation on IPv6 support for multiple routers, multiple interfaces, and multiple prefixes. First of all, I would like to explain what this is about, multi-router interface and prefixes. For the remaining of the presentations, I will be calling it multi-IPv6. But so I don't repeat all this. So what do we call multi-IPv6? These are scenarios that, from the standpoint of the host of the system that connects to the network, will have multiple routers, multiple interfaces, and/or multiple prefixes. And if sounds odd, and you say, well, does that occur in practice or not? Well, this is quite common, even though we don't even stop to think about this. An example of this could be having a laptop that connects to the internet via Ethernet and Wi-Fi interfaces, for example. The other case could be that you have in your home or in your office a local network with two internet connections, and of course that is so that in the event one fails, you're not fully disconnected, and this has been quite usual after the pandemic and so on. And then you have other cases that you don't even stop to think about. For example, having a mobile phone. Normally you have a mobile connection, LTE or whatever, and if available, you also have an additional connection that could be a Wi-Fi connection. So these are all potential scenarios which are common. And basically, one would expect this to work well. One might expect to have two connections at home and say, well, I connect this, and if one crashes, the other one will work. Now, in practice, when we look at this in reality, these scenarios don't work so well. Or expressed differently, these are scenarios where that somehow do work. This doesn't crash badly, but if you have two connections, you turn off one and you use the other one. So this is the typical case is that of mobile phones. If you have a mobile connection and you connect to a Wi-Fi network, it's not that the two are connected at the same time, but the mobile cancels the mobile connection and only uses a Wi-Fi connection. From my standpoint, these are scenarios that one would hope would be better supported. Then you have some details. You might say, well, I don't want to cancel or turn off one of the interfaces so that this works. Or one might also have the expectation of saying, well, I have a switch at home, and what I wish to do is to hire two ISP services, connect the routers of each ISP to the switch, and if one fails, you use the other one. So these are not scenarios that are well supported. What I will try to explain here, this is a super simple example. This is a hypothetical case. I'm going to speak about a simple case of a multi-IPv6 scenario. This would be the case of a home office where you have a local network. The LAN, for example, we can consider that a switch, and basically I have two connections to the internet with ISP A and with ISP B. And I have my systems connected to the local network. To add some more to this scenario, you will see that in ISP8, the router connecting me to ISP8 is router A, and the same for ISPB with router B. And to add some more color to this, I added two things to the ISP. One is a recursive DNS server. The one you have at the top in each case is the DNS server to solve queries, to solve domain names, and I also added a copy of a website that is supposed to be a local cache. So you have the site example.com. So each of these IXPs has a copy. So these could be content distribution networks or whatever. So to set the situation, we'd like to say if I would like to forward a request to the site example.com, what are the steps or what are the decisions that I should make? So, for example, these are decisions that I have to make. So, something else that I had skipped, in the case of the two routers, the two of using Slack, so each of the routers announces configuration information to the local network, and the host below takes all this information and stores it in the data structure. Let us assume then that in my host, the one down there at the bottom, has access to the site example.com. The first decision that I will have to make, the decisions that I have to make, involves deciding which recursive DNS server the query will be sent to, because I have two, one for each connection. So in principle, I could send it to A or to B. So that would be the first decision I have to make. The second decision I have to make is that if I already know what DNS server will be receiving the query, I then have to select an origin IPv6 address. The packet has to leave with an address. So there you have a second decision to make. The third decision is that no matter it doesn't matter if I already selected the address for the DNS queries, I now have to decide which of the two routers will use, through which of the routers I will be sending my query, my DNS query. The two options. So let us assume I have step 1, step 2, and step 3, and the 3 did work. I sent the query, I received the answer, and now I know the IPv6 address that I have to connect to. The next step that I have to take, the next thing that I have to decide is to choose an origin address that I will use prior to the queries made to the website. I know what website I'm going to contact, but because I have multiple addresses, I have to decide which one I will be using. And the final step, once I chose the origin address, I still have to decide which of the two routers will be used to contact the server. I had more than one option. So quite obviously, the spoiler here is that in those cases in which I just have one router, I don't have to make any decisions because I have no options. So I can choose or I will not choose. But in scenarios such as these multi-IPv6 scenarios, when I have more than one option, I have to make a decision, and that is where the problems arise. So having explained all this, and to give you some context, because you might have seen the previous diagram say, well, there shouldn't be any issues there, but to give you some context as to the origin of the problem, if one thinks about the Slack protocol, which is for auto configuration, the premise of Slack is that if I am connected as a host to a local network and that local network has several Slack routers connected to it, each router will advertise configuration information. And it is supposed that somehow or other I will realize how I have to use that information. In other words, each router advertises the configuration information, what are the prefixes I have to use, what DNS service it has, the router, the default router, and with all that information that I have potentially from many local routers, I will be in a position to decide how I will use that information. And that is where things are not so straightforward. When you only have one router, I go back to the previous example, you are deciding this, but you have no options. You just have one option. When we have cases as the one I have just described and each of these multi-IPv6 scenarios, we have multiple options for everything. We have multiple recursive DNS servers, we have multiple default routers, we have multiple prefixes for the configured addresses. I have to make many decisions. Now, the reality is that in the practice of multi-IPv6, this works very badly, or it doesn't work at all. So one of the things that I will now share with you during this presentation is many of these scenarios. Some are sort of more complex, if you wish, and well, you should know specifically about the standards involved, but this is not relevant to understand the whole problem. So from all the scenarios the potential scenarios, which are quite a number, I will focus on two that are very common and very straightforward and simple.
What I'm going to show, or I'm going to walk you through this so that you may see the problem we have. And then I'm going to make an attempt, to the extent possible, to discuss or propose solutions to approach this issue. So, let's go to the first scenario. This is basically the same scenario we had in the past. We had the same story, the Vox IXP, the ISP, I have it connected to the middle, and each has its recursive DNS and the cache of the site sunproof.com, and somehow each of those routers give me information of configuration in the local network. In this case, the first router, router A, announces 3 parameters implicitly as who sends the configuration data. Router A says, if you wish, you may use me as a router by default. That is one of the configuration parameters, and the other is that router A will announce the recursive DNS, or DNS A, yours, and another thing, it will announce the network prefix that we assume that you need to use to configure the addresses, like. And router D will do the same in essence. I marked it in red and in yellow the information of each router, and what I tried to show there in the middle, what you can see in orange, is that the host that is connected to the local network unifies all the information. That is, it's not that it keeps them separate and it says, well, in this side we have all the configuration info given to me by router B1 and here router 2, but it merges all the information. Examples that you could mention today, it's not so much so, but in Linux systems, for instance. But you could think that, for instance, the information of the recursive DNS servers, both addresses will end up in /tc/resolve in the Unix type systems, and there's nothing saying that now notice that this DNS system announced this system or that other. No, that's not what happens. In a way, the host, in this case the one that we have underneath, has no more record of which was the Slack router, the local router that provided each piece of information, and somehow it integrates all the information in the same data structures. Now, let me give you 3, or you might have more examples, but to make things quite apparent, let me give you 3 examples. Those are the ones that you have to your right, the bottom, 3 things that could go wrong. First of all, let's assume that I'm the host that is there at the bottom, and I decide that I'm going to send my DNS request to this DNS server that is up here. So, based on the current standard, you can use any address, whichever you like better. You're not required to use the address space of one ISP or the other. Imagine what could happen if my host here at the bottom says, well, as a recursive DNS server, I'm going to use this one, but just because I can't do it, because I like it. That system uses the address space of ISP A, right? This A prefix. That is, I'm using as a for my request, I'm using the ISPA, but I send the queries to the ISPB, and so you might wonder, so what's wrong with that? Well, one best practice is considered that if an ISP is going to have a recursive DNS, it's considered good practice only if that recursive server only provides service to the clients of that same ISP, avoiding what is called an open resolver. That's the jargon. So we assume that this DNSA server will provide service only, or will allow queries following this prefix, and this B server will provide service only if the addresses of origin use this prefix. Now the host, this one here, just because it doesn't know how to do it any better, or because it can, or because it likes to, sends the queries here, but using this address space. If this server implements ACLs just to provide service to these ISP client, those packets will get blocked. It won't respond. So clearly there you have a problem that would result in a timeout. I send requests to one place, but using server, well, here the packets get discarded. There are other things that may happen. Let's assume that I want to send traffic this way through router B, because that's what the routing table told me to do, and so I'm going to use this router for the outbound traffic. So what would happen if the traffic that I'm taking from router B, instead of using the ISPB address space, uses that of ISPB A? I want to get out from here with this address space. What will happen in those cases is that if the ISP in question is applying the so-called exit filters, it says you're sending me packets with an address that you're not supposed to be using. It's going to discard traffic. That is, you use the wrong addresses of origin to leave it to come out this way. So the router discards the packets. So there you have another thing that could go wrong. And another thing that could happen too. Let's assume that what we said earlier was no problem. No problems appeared. So, but when I want to visit that site, that's site.com, I could have sent my DNS request to this server. In the scenario we mentioned, this is a cache for this ISP. If I want to resolve with this DNS example.com, we assume that it's going to be mapped to the IP address of the system, this cache. Now, what would happen if I now want to contact this system? I'm going to do it through router A, and I do it with the addresses of router B. Even if this system, for instance, if it didn't apply exit rules, it is very likely that the cache itself may apply them. Because if you are this ISP, you don't want them to use your cache to provide services to the people here. It makes no sense, clearly. So there you have three potential scenarios. And some people might say, well, where does the problem lie? Well, the problem lies on this that we're doing here. This is the standard behavior today. That means that you are mixing the information you get from different Slack routers all in the same place. And some people might say, well, how could we solve this? Well, there we go to the most obvious. The solution should be, well, the difference obviously is down here compared to what we had earlier with this here, where we had it all together. The solution would be to preserve the information announced by each router separately. That is, that everything a router announces, well, you should consider that as an atomic data block. If you are going to use this DNS, then whether you like it or not, you're going to have to use this router in addition to using the prefixes of this router. And even once you completed the resolution, as you did it with this DNS, when you send traffic to the web server, you use the info of this same router. That is, you don't mix the use of information of a router with the other, right? This would somehow be the solution. And the question here is, well, so if this is the solution, why don't we solve that? And if in theory we know how to do it, here there's an issue, that is that the implementation is not as simple as that. Or as a matter of fact, that the systems, with the current systems, the information is not preserved like this. I don't want to go into details because the presentation would be too long, too lengthy, but the idea is that you would have to make a lot of changes in the implementation of a host, because today, and for millions of years, the way they work is mixing all the information. So this is one of the problems, right? And I brought another one here. This is, if you wish, this is a more simple case, but it's always also aiming at the same. This is a hypothetical scenario. Some people will say, well, I don't know whether in real life that would happen, but the idea is to put it as an analysis exercise. Let's assume that we have a situation like this. Basically, it's the same as before, everything equal. The only difference is that now both ISPs are sharing the same DNS server. So some people may say, well, who's going to do that? Well, it's an example just to understand what the problem is. Even though the case could be, because some people do it, that in practice, if the DNS that is announcing this and this, for instance, is Google's DNS or Cloudflare, well, there it's no longer hypothetical, because there are many people that do it. Whether it's right or not, that's another issue. Let's assume that in principle we have two systems announcing that information. Each one announces its router, its prefix, the DNS server, etc. Let's assume that for X reason, it's immaterial. Why? This ISP here now says, well, I don't want you to keep on using this DNS, right? Because whatever. Because the guy, well, no matter why. So how do you do that in Slack? How can you have a certain part of the information not to be usable any longer? You can do that with 0 lifetimes. That is, when you announce information with a recursive DNS, there's a timer that tells you how long you can use that information. So as this ISP says, well, I don't want you to use this DNS server anymore, now it
¿Qué es lo que pasa?
it announces it with a lifetime of 0. So what happens? In the normal cases, when you are working with Slack, the way it's implemented, as all the information is put together, what I said earlier, that I put the entire thing in that orange table I showed earlier. If this ISP told me that I cannot use this server, this host assumes that this DNS server cannot be used with anybody. It's as if you said, well, I announced that 8.8.8.8 has a 0 lifetime, and now, no matter how many routers you have, even if you have 20 routers telling you use that DNS server, as the lifetime is 0, nobody can use it. So what should happen? Well, what we have here, just as we said earlier, the information announced by each router should be kept separately. So if I manage to preserve the information separately, what's going to happen is that with respect ISP A that we have here I'm going to have a prefix that announced it. I know that the default router will be router A, and I know that I can use the DNS A server because this ISP is announcing it with a non-zero lifetime. On the other hand, if I look at the appropriate information, the one that corresponds to ISPB, now the prefixes continue to be the same, the default router is still the same. The only thing I did was to eliminate the DNS server, because here we assume that I'm announcing it with a 0 lifetime, and there was no alternative DNS announced. A DNS server announced. So what I'm describing here applies not just to DNS servers. I did it because it's the easiest case, but this problem applies to all sorts of Slack data. That is, if you have two different upstreams, the ISPA may interfere with the information announced by ISPB. And why? Because the host puts all the information together, right? So the solution here is keeping things separately.
So you might say, well, if that is the solution you have implemented today, well, no. Could it be implemented? Yes. But this is something that I personally think the community has to drive forward, has to push. And this is because it's quite reasonable to say, well, I want to have a scenario that looks like this. And if you wish that scenario couldn't be working better than with IPv4, you might say, well, at least in IPv6 would like to have a switch. I connect the two routers. If I wish to connect 4 or 5, this should still work. But this is not possible today. So what are we doing in this regard? Because my idea is not only to describe a problem and say, well, this is a guy who's saying that everything is working badly and it's like collective suicide. But the intention is that to identify problems and find solutions to make things work better. So it's about identifying the problem, working on this, and figuring out solutions. What I did was publish 2 drafts. Those of you who are familiar with IETF, one aims at the V6 ops group. This first draft describes the problem, what I have just explained, maybe with more technical rigor and examples. And there's a second draft focused on the 6-man group, which is one in charge of standardizing the protocol itself in order to implement this solution. One of the issues that I stressed, because of course when we refer to this, they say, well, this was solved with this X thing that was approved and standardized, but nobody used it. So one of the things that I stress a lot is that the solution to this problem, and this is what I'm proposing, is that you should solve this by modifying things on the host only. If you aim at solving these with changes to the routers, the network will be less robust, and this will ultimately not depend on you. If you think about a home router, this is assigned to you by the ISP and it is never updated. But in the case of host-only, updates is something that is far more likely to do in the short term. In addition to that, insofar as I am using an implementation that has these improvements, even if the network does not collaborate, my system will now work correctly. So we should always be aiming at that. When you want to find a solution to a problem, this solution should not require coordination with a lot number of parts and systems. If I can solve everything from one site only, so much the better. And if I can solve it from the host alone, so much better, because this would lead to having a more robust network. So these 2 documents, these 2 drafts, were presented to the IETF, and the idea is to propose a solution, to discuss the issue. It is important because sometimes problems whose solution is not so simple and we want to make things work, it is often helpful to focus on understanding what the real problem is, to define the problem, and now that we have the problem that we all agree that has to be solved, we can propose solutions. We might agree on one part or not on another part. So, conclusions. basically, these multi-IPv6 scenarios are at present currently broken. If they're not broken, the typical mobile phone connects to the network, Wi-Fi and the mobile network. It is like a trick. So you have these interfaces active. I shut one down. But I personally think that this should be done better. The second point is that there have been past attempts to improve this, but with solutions that depended on introducing new protocols, and I think this won't happen in practice. Personally, I think that these scenarios should be addressed because we're in a situation where IPv6 could do this better than IPv4, but we should have solved this problem. Now, the obvious thing here is that if someone says, I don't want to solve these problems because it is difficult or for whatever reason, there's only just one alternative, but an answer with 3 letters, NAT. The only solution would be that. Otherwise, you can solve that with that. Yes, you can solve it with NAT, but let us do something better. We can solve this in a different way. So, do you have time for questions or comments? We have time for 2 questions. Hello, I'm Douglas from SN. Congratulations on your presentation. It's a great presentation. Regarding that, what I'd like to say, no, please don't do that. Already tied to that. It does work, but all the things that depend on the protocol and on the upper layers gets broken because they trust on the other layers. So that's not at all good. So I, in fact, don't have a question to ask, but what I like to do is to include other problems into analysis, applications that respond to the OS of the DNS, applications that use their own DNSs. This would be some additional complication. And then you have 464 XLAT scenarios where PLAT for IPv4, outbound IPv4, use global IPs. So that ends up becoming a greater problem. So in your analysis, when you use the block and the RFC allows you to use global blocks for mapping purposes, then, well, I don't know, maybe to have an opinion in that sense.
Disculpa, ¿puedes repetir la pregunta?
Could you repeat your question? In your analysis, can you analyze these 2 complications, DNS in an application layer and 464 XLAT? I take that into account, but I can add it. Jordi Palette. In addition to NAT, the other obvious solution is provider-independent addressing. That's very expensive. Yes. Now, do you really believe that if we manage to standardize this, and hopefully this is possible, but things are not so straightforward at IETF, not so easy at IETF. The OS vendors they implement this with many things that should be included in the OSs and are not. And on the other hand, we can assume that this is implemented typically in Linux, Windows, and Mac OS. But what occurs with all those other devices in the homes that are embedded and end up having the same problem? Well, unfortunately, of course, I think the host solution is better than the other one. But of course, things do take time. And if we wish to be positive, okay, let us continue with the problem for a number of years, but once the devices are renewed, then the problem will disappear. But you trust that this will be implemented? Have you spoken to the people at Microsoft? Well, I cannot say yes or no now, but based on my experience, the more important part or the most difficult part is to sort of break the ice. I worked a lot on IPv6 addresses. I did a lot of work there. The first to implement this was Linux and Mac OS, and then when everyone is doing it, okay, it does take years. Things I did in the field of addressing took about 7 years, but I mean, I cannot assure the certainty. We have to try and find a solution. If it happens, well, I don't know. So thank you, Fernando. A big round of applause.